Welcome pre-cal students to class today on this Wednesday the 12th. I do want to start off by saying that I made this video early this morning, probably at 7:30 in the morning. I saved it, uploaded it, and then I always checked the video. When I pushed play, there was no volume. So I'm making this video now Wednesday at 9 o'clock in the morning. I know it's a little late, but do understand when you listen to this video, I was not lazy or negligent to do a good job, just the volume malfunctioned. So that's what happened. I do apologize. And when I'm done making this video, by the way, I have to run over to Bree and Mike tore his pants over there, so I have to take him a replacement pair of pants. That's 30 minutes there, 30 minutes back. And so the homework video that goes along with this video probably won't be posted till around noon today. And again, these are just things that happen. I apologize. I know you guys understand, so let's continue on. Okay, announcements first. We will have a quiz on Saturday, so I know you're super excited about that. So be looking for that. Your tests are due today. All questions answered. Your test totally completed, turned in. And integrity sheets. Please don't get behind on those. Do your videos and your homework every day, okay? And here we go. We are going to continue moving through Chapter 2 very, very quickly. Today's math should look very familiar, but do understand we are going to cover a lot of this familiar math. So when the math should be easy and familiar, I do tend to go a little quicker, which is why we call this pre-cal class. It's an advanced class. The homework at the end will seem long, 1 through 81, but notice it's every other odd. And that's only 21 problems. An average homework assignment for me is around 15 to 20, so that's pretty normal. And plus, you'll see they're pretty easy problems. We'll be looking at 2 topics today. Topic number 1 is called imaginary numbers. Topic number 2 is called complex numbers. So this is our goal today. Both of these topics should look familiar to you. And let's go ahead and continue on. Your first heading is imaginary numbers, lesson 2.2, and the date today is the 12th. Imaginary numbers, lesson 2.2, and the date today is the 12th. Please remember that you can never take the square root of a negative number. And let me show you why very quickly. If you have the square root of negative 4, the answer could not be negative 2, because negative 2 times negative 2 is a positive 4, and you want a negative 4. The answer could not be positive 2, because a positive 2 times a positive 2 gives you 4, and you want a negative 4. You can never take the square root of a negative number. Because of this, mathematicians have decided to use something that will symbolize the square root of negative 1, and we use the letter I to represent the square root of negative 1. So for example, if I had the square root of negative 4, I could rewrite that as the square root of 4 times what? Negative 1, because 4 times negative 1 is negative 4. And then what is the square root of negative 1? Well, it's I, so cross off the negative 1 and put an I. In other words, you simply change the 4 to a positive and put an I on the outside. And so that's what we're going to do today. If you're a little lost there, it's okay. I'm going to explain that more in detail later, but do understand that we use I to represent the square root of negative 1. Now, remember this. If I equals the square root of negative 1, and then I chose to square both sides, if I squared the I would get I squared. And if I squared the square root of negative 1, anytime you square a square root, you get just what's on the inside, so I would get negative 1. So please don't forget that if I equals the square root of negative 1, then I squared equals negative 1. Okay? That's very important that you remember this right here. Let's go ahead and simplify some square roots using this information. I really don't feel like today's video will be very long. It should be pretty short. So let's go ahead and get started and see how we do. Anytime you have the square root of a negative number, you simply change the number on the inside. We call that the radicand. You change the radicand to a positive number and then put an I on the outside. It's that easy. So the square root of negative 7 would simply be the square root of 7i. Now, if I asked you to type that into your calculator and put a decimal number right here, that's fine. For right now, we're just going to leave radicals, okay? Now, let's take a look at the square root of negative 16. I'm going to make the negative 16 a positive 16, And when I do that, I must put an I on the outside. Now over here we were finished because 7 is not a perfect square, so I could not take the square root of 7, but I do know the square root of 16, which is 4. So my final answer here would be 4i. Okay? Now you know I go fast on all my videos, and then it's your job to back it up and listen to it again if you need to. I'm going to change this problem here to 18. There's a reason for that. So let's go ahead and change this problem here to the negative square root of negative 18. Now I know there's a negative sign here, and that's fine. We're going to worry about that later. First of all, I'm going to change the negative 18 to a positive 18 and then put an I on the outside. Now 18 is not a perfect square. I do not know the square root of 18, just like over here I did not know the square root excuse me, of 7. So you might think you're finished like this, but you're really not. The difference between this problem and this problem is very simple. I cannot simplify the square root of 7, but I can simplify 18. How do I know that? Because there's a perfect square that divides into 18 evenly. And that perfect square is 9. So really, instead of putting 18, I can put 9 times 2. And the reason I would do that is 9 is a perfect square. Now some students might put 6 times 3. That's not going to help. 6 is not a perfect square and 3 is not a perfect square. Okay? But 9 is a perfect square, so cross off the 9 and put a 3 on the outside. When you do that, the negative sign will come first, then the 3, then you're left over with a 2 on the inside, and then the letter I. Look at that. So this problem here simplifies down to this. If you need to back it up and watch it again, please feel free to do so. Okay? All right. Now this last problem here, a lot of students would say, oh, I'm multiplying two radicals, so I'll multiply outside numbers times outside number, that's 6. And then I'll multiply inside numbers, or radicand times radicand, that would give me a positive 12. And you're right, normally you would do that, but don't forget in math there is such thing as called order of operations. And when it comes to radicals, you always must first eliminate your negative radicands. If you don't, you will miss the problem. So in other words, before you multiply these two radicals together, you must first make the 3 positive and put an I right there. And then in the next radical, you must make the 4 positive and put an I there. Now you're ready to multiply outside number times outside number. That would be 6. And then radicand times radicand, 3 times 4. And then you must also multiply I times I, which is I squared. Now, we do not know the square root of 12. 12 is not a perfect square, but it can be simplified. There is a perfect square that goes into 12, and that perfect square is 4. 4 times 3. Now, we do know the square root of 4. Cross off the 4 and put a 2 on the outside. 2 times 6 is 12. You're left over with the square root of 3. And then see this I squared? Don't forget, I squared always equals a negative 1. Please don't forget that. So where the I squared is, I'm going to put a negative 1. Now, what you really have is this. All of these numbers written side by side simply means 12 times the square root of 3, excuse me, sorry guys, times negative 1. Now, think about it. If I had something like 2 times 3 times 4, could you not multiply the 2 times the 4 and put an 8 and then put times 3? Sure you could. It's the same thing. You still get 24. So we're going to do the same thing here. My voice is really raspy. Sorry, guys. We can do the same thing here. Let's multiply 12 times negative 1. That gives me a negative 12. And then bring down your square root of 3. And that's it. Now that is the answer you must put on a test or a quiz, okay? That's exactly how you need to write your final answer, okay? So that's a quick little review teaching lesson on how to simplify square roots using imaginary numbers. Okay guys, I'm back. You probably saw me pause the video. Whenever I go like this and then that over here, I'm pausing the video, and I had to talk to my boys about something. So anyways, I hope this makes sense. Let's continue on, and let's also look at simplifying complex numbers. Okay, that's the second topic of today, simplifying complex numbers. So if you want to write down the heading, we're dealing with complex numbers, lesson 2.2. And of course, even though it seems like it's been probably a whole day, the date is still the same, 3/12. Now, let's quickly review what a complex number is. Notice that when I put a real number with an imaginary number as two terms, like right here, we call that a complex number. So a complex number is a combination of a real number and an imaginary number put together. Okay, and also notice how this is written in standard form. Standard form is a plus bi, and you really need to know that. When you simplify complex numbers, I really want your answers to always be in this form. You put your real number first, and you put your imaginary number second. Okay? All right, let's continue on. We are now going to do a lot of simplifying. Look at these problems down below and make sure that you see the difference between each one. Now, the first three right here are the ones I want you to focus on first. Do you see how I have a complex number here, a complex number here, and I'm adding them? Over here I have a complex number and a complex number, and I'm subtracting them. Here I have a complex number and a complex number, and I'm multiplying them. Do you see that difference? If not, take a minute and really study these, because each one is done differently. Or excuse me, is simplified differently. And if you don't understand the difference between each one, then you're going to be confused. Okay, so look this over and make sure you see the difference. Over here, the last two are pretty similar. I mean, here we have a complex number being divided by a complex number. Okay, that's pretty obvious. And here we have two complex numbers. They're both division, here and here, and they're being added together. And so they're pretty much similar problems, and notice we already have a common denominator, so it's not going to be that difficult to do. But my point is we're dealing here with fractions of complex numbers, okay? And so we're going to have to learn how to simplify those also. And by the way, when I say simplify these, what I mean is when you're all done, you should write your final answer like this: A plus bi. Your final answer should look like that. Okay? So without any more hesitation, let's jump into these and see if we can't learn how to simplify these. Let's go ahead and take a look at this first problem here, students. I think you'll find this one pretty easy. I mean, look guys, we have a complex number and a complex number, and we're adding them. So you simply add your two real numbers, 8 plus 3 is 11, and you add your imaginary numbers, and that would be 13i. Please don't put I squared. We're not multiplying, okay? We are just combining like terms. And look at that. It's in a plus bi form. Here's my a, and here's my b. Okay, so that's pretty easy when it comes to the addition part of complex numbers. Really not a lot of time to spend on that. I hope that makes sense. That's pretty simple. Now let's go ahead and take a look at the subtraction problem here. This one has an extra step. If you want to take 4 minus 6 and put a -2, and then take 5i minus a -3 and put a +8, that is totally acceptable. For me, I usually take no chances with my signs, and I usually make this a positive, and you're allowed to make that a positive as long as you go in here and change all your signs. So now I have a -6 and a +3i, and now I just simply add. I hope that makes sense. Whatever method you want to use is totally acceptable. I like to make the negative sign here a positive and then change all of the signs in the second parentheses. So 4 and a -6 gives me a -2, and 5 and a +3, a +5 and a +3 gives me a +8. Notice either way you get the exact same answer. I warned you at the beginning of the lesson that this is a pretty easy video, okay? It's It's not going to be that long. It's pretty simple, yet we're covering a whole lesson and you're doing plenty of homework, okay? So we're going pretty quickly. But that's how you would subtract imaginary, or excuse me, complex numbers, okay? That's pretty simple, but back it up again and watch it if you need to, but that's pretty simple. Now let's go ahead and take a look at this problem right here. Here we're going to multiply two complex numbers. Well, guys, you know how to multiply a binomial times a binomial. I take this I and I multiply it through, or this 1 and multiply it through. 1 times 1 is 1, and 1 times 3i is 3i. So I can cross that off. I'm done with it. Now I take this 2i and I multiply it through. So 2i times 1 would be a positive 2i, and 2i times 3 would be a positive 6i squared. So now I'm done with this. So I took the 1 and I distributed it through. Then I took the 2i and I distributed it through. And now I'm ready to go ahead and add like terms. So, well, first of all, you see this I squared right here. It's 6i squared, or 6 times I squared. So let's not forget, for I squared, I really need to learn to put that -1. Okay, so if I put a -1 here, 6 times -1 is really a -6. So I have a positive 1 and a -6, that's a -5, and then a positive 3 and a positive 2 is a positive 5i. So there we go. I multiplied two complex numbers together, and once again, I got out an answer in standard form, which is my goal. Okay, I hope this is making sense. Let's take a look now at how we would simplify. Definitely don't want to do that. Let's take a look now at how I would simplify two complex numbers that are being divided. Okay, please take some notes very carefully. First of all, you always multiply the fraction by the conjugate of the denominator. Let me say that again. First of all, you always multiply the fraction by the conjugate of the denominator. You're probably saying, well, Mr. Earhart, what's the conjugate? Well, I'm glad you asked, and let me show you. If I asked you for the conjugate of 3 plus 2i, it would be 3 minus 2i. If I asked you for the conjugate of 6 plus 2i, the conjugate would be 6 minus 2i. If I asked you for the conjugate of 2 minus 5i, it would be 2 plus 5i. If I asked you for the conjugate of 1 minus 6i, the conjugate would be 1 plus 6i. Conjugate is spelled like this. Okay, conjugate. Now, what you do is you look at your denominator and you simply change the sign of the imaginary number. Notice you do not change the sign of the real number. I have a positive 1. I leave it a positive 1. Okay? So when I say take the conjugate of the denominator, what I'm really saying is simply change the sign of the imaginary number. And now we're going to multiply this binomial times this binomial. And we're going to multiply this binomial times this binomial. Mr. Earhart, why can you do that? Well, you're allowed to multiply a fraction times anything as long as you do it to the top and the bottom. For example, if I had the fraction 1/2, I could multiply that by 3 over 3, and I would get out 3/6. And 3/6 is the exact same thing as 1/2. Okay, so I'm multiplying the top and the bottom by the exact same thing. Well, I'm not going to bore you to death with a lot of details on multiplying a binomial times a binomial. You guys know how to do that, so I'm simply going to do it very quickly. You would get 2 times 1 is 2. For your I terms, you would have, let's see, a positive 12 and a negative 5. Positive 12 and a negative 5. That would be a positive 7i. And then you would have a negative 30i squared. Okay, but we know for I squared you really have a negative 1, and a negative 30 times a negative 1 would be a positive 30, and positive 30 and positive 2 would be a positive 32. So if you multiply let me get rid of this mess here real quick. if you multiply the top binomial times the top binomial, 2 minus 5i times 1 plus 6i, you will get this right here. Okay, this is exactly what you'll get. Now let's multiply the denominator times the denominator, and I'm going to go ahead and do this one for you so you can see what happens. It's really cool. A lot of stuff's going to cancel out. 1 times 1 is 1. 1 times 6i is 6i. Then negative 6i times 1 is negative 6i, and negative 6i times positive 6i would be negative 36i squared. But for the I squared, I'm going to put a negative 1. And negative 36 times negative 1 is a positive 36. And then a positive 36 and 1 is 37. And look at this. Look at what happens to your i's. A positive 6i and a negative 6i, they cancel out. That's always what's going to happen when you multiply a complex number times its conjugate. It eliminates the i's. Excuse me. And so that's why we did that. That's why we multiplied the denominator times its conjugate to get rid of the i's. Okay, so now when I took 1 minus 6i times 1 plus 6i, the answer that I got was 37. So I'm going to put the 37 right here. Okay, and now I'm going to go ahead and write this in standard form. So 32. Now watch how I do this. Very important you see this. Watch. I take 32 and put it over 37. So 32 over 37. Now whatever this sign is, you put that right here. Okay? If this would have been a negative right here, then you would put a negative sign right here. Okay? So make sure you understand that. So I'm going to put a positive sign right here. And then whatever's in front of the I, it's a 7. I'm going to put 7 over 37, and then you put your I right here. You do not put your I in the numerator. You put it right here. And look, I have standard form. This is A plus BI. So you took two complex numbers that were being divided, you multiply the top and the bottom by the conjugate, you got this, and then you wrote it in standard form. This expression right here that I'm circling equals this right here. Okay, so there we go. One more and we're done. I told you the video today is pretty short, and I think it's pretty simple to understand. Okay, all right, well here first of all, notice we do have a common denominator already. So if we have a common denominator, you write your common denominator once, and you add the top because of a plus sign right here. So if this was a minus sign right here, then we would minus the two complex numbers. 3 plus 6 is 9. 2i plus 2i would be 4i. 4i. There we go. And now you should know what to do. I'm going to get some space here. You should know what to do. We just did it a second ago. Whenever you have two complex numbers they're being divided, you multiply the top and the bottom by the conjugate. So the conjugate of 1 minus I would be 1 plus I. And we do that so it eliminates or gets rid of all of the i's in the denominator. So here we go. If you multiply 9 plus 4i times 1 plus I, a binomial times a binomial, you will get 9. Let's see, 4i, 9i, that'd be 13i. And then 4i times I would be a positive 4i squared. But of course, I squared is negative 1. And 4 times negative 1 is a negative 4. So we end up with a negative 4 right here. And 9 and a negative 4 would give me a 5 plus 13i. So there we go. I just quickly simplified the numerator. And I probably shouldn't have done that. We'll bring it down here. There we go. 5 plus 13i. Now for the denominator, I'm going to once again show you what happens. 1 times 1 is 1. 1 times I is a positive I times 1 is a negative I. And then I times I, negative I times I would be negative I squared. These cancel out. A negative I squared really means a negative, then a negative 1. Which is a positive 1, so you have 1 plus 1, which is 2. So your denominator becomes 2. So now we simply write 5 over 2, and then whatever sign you have right here, that's the sign you put in the middle. And then whatever you have beside the I, the coefficient of the I is 13, so 13 over 2, and then you put your I right here. Look at that. Pretty simple, guys. It really is. Okay, I hope this has been easy for you to understand. There's your homework assignment, page 191, numbers 1 through 81, every other odd. Please do your homework well. Please do it diligently. Call or email if you have any questions. All right.